我们下一个 session 是谈怎么用 Kubernetes 去操作 MySQL。那尤其是我们知道 Kubernetes 它是一个它是 abstraction 的一个架构。那在 Kubernetes 上，我们可以，因为像我们有很多所谓的多 instance 啊，比如说你有主从架构，或者是你有 InnoDB Cluster。
You see the present now button, right?
我们经常介绍
Yeah, and then you choose your screen, entire screen, and just click.
然后怎么去 create 一个 InnoDB Cluster？ 那从这边可以看得到，怎么去利用大量的 InnoDB， 然后融进去。
There's yeah, just click entire screen and then click share.
Okay.
Hananto, you can start now.
All right.
Yeah, they can hear you.
Thank you so much, guys, for all the help. Good afternoon, everyone. Okay. First of all, before I start, allow me to introduce myself first. Right. My name is Hananto. I am MySQL Principal Solutions Engineer. I work for Oracle MySQL, and I'm based in Singapore. I'm very excited and happy today to have this opportunity to share the theory, techniques, methods, concept, tips, and tricks on how to deploy MySQL database on cloud native, especially Kubernetes, how to do backup recovery, and how to deploy MySQL clustering solution using InnoDB Cluster on Kubernetes. To complete my presentation for about the next 45 minutes, I will do live demonstrations as well to demonstrate how the method can be used to deploy MySQL on Minikube. I'm not going to use full-blown Kubernetes cluster because I only use my laptop as simulation. However, if you are interested to deploy MySQL on Kubernetes cluster, you can apply the same concept. There are slight modifications need to be done if you want to deploy the YAML file definitions on Kubernetes cluster, because socket file cannot run on cluster file system. Technically, you might need to have a config map to locate the socket files inside the my.cnf. Later on, I will explain to you into internal directory of a container so that MySQL database can run. On InnoDB cluster, the only change between Minikube and Kubernetes cluster is to have IP whitelist being set when create cluster and add instance. All right, let's start now. This is Oracle safe harbor statement, and allow me to pause a while to give opportunity to read. Here with the agenda today, I will talk about using MySQL on Kubernetes, whereby I can explain the reason from business as well as from the technical angle, why it may be beneficial to have MySQL database workload running on container. I will also explain and demonstrate how to deploy MySQL on Kubernetes as a stateful application on a stateless environment like Kubernetes. And then I will explain and demonstrate various techniques using MySQL utilities and features to perform backup and recovery on Kubernetes. And I will also explain and demonstrate the techniques to deploy MySQL InnoDB cluster 3-node but on Kubernetes. And last, I will close my presentation today with summary on key takeaway and important points for my presentation. Containerizing MySQL on Kubernetes. I'm going to read from Wikipedia the definitions about cloud native. Cloud native computing is an approach in software development that utilize cloud computing to build and run scalable applications in modern dynamic environments such as public, private, and hybrid cloud. This kind of model allows applications to run everywhere. As you see on the screen, more and more organizations across the globe implementing cloud native. You maybe don't know if currently, based on survey conducted by Forbes and CNCF, 71% of Fortune 100 are using cloud native, and 73% of them are currently using cloud native for their production environment. It makes sense that the survey found the year-on-year adoption rate of this cloud-native computing technology across the globe can reach tremendous statistic numbers like 267%. It means that every year, the numbers of organizations on this planet that use cloud computing is jumping by more than 2.5 times. This slide presents the business justifications why people are adopting cloud native. Based on survey conducted by IDC, cloud-native computing is able to reduce capex by 47% from reductions in PMs, software licensing, and server costs, and reduce OPEX by 10 times from pay-per-use and managed service costs. The cloud-native can improve development velocity up to 13 times. More software can be quickly released and help to improve the agility of the business to face competition. With more scalable, portable, and highly available application, it found that 75% organization can improve their efficiency in maintenance and support of ongoing operation. CNCF, or the Cloud Native Computing Foundation, is a Linux Foundation project that was founded in 2015 to help advance technology, container technology, and align the technology industry around its evolution. Again, I'm quoting from Wikipedia. The diagram on the screen is the CNCF's recommended path to the cloud-native landscape. As you see over there, MySQL is within the landscape. MySQL is very good technology to go if you think about cloud-native. As you may know that DB Engine places MySQL as #1 open source database technology that currently widely used around the world. This slide talks about technical justification, why people are moving towards cloud-native computing by containerizing their application. Technically, the provisioning of the entire application can be done very quickly in the containerized deployment compared to traditional deployment and virtualized deployment. It just requires the container image to be deployed to have the whole stack needed for applications to run without effort to reinstall them each time, started from the necessary hardware, operating system, application development, and setup. If any issue, any problem, applications can be easily to return to the initial state as per container image, and containers are made for fast scaling as well. More and more people think to bring data layer much more closer to microservices applications that run on container. By close proximity between application, microservices application, and database, and have a unified platforms across database and application, people expect performance, stability, and efficiency in supporting both application and database. For the same reason, they expect fast provisioning, flexibility in configurations, while providing storage to store data persistently on the disk. We talk about business justification of people migrating their apps to the cloud native. We talk about the technical justification, why applications is a lot better to run the cloud native. We also covered about bringing database service much more closer to the application. This slide particularly talk about why you should think of MySQL when you want to do so. MySQL is extremely portable. It can run on bare metal, VM, or even on cloud-friendly environment. MySQL is extremely flexible in terms of kind of storage that you can use. MySQL can use block storage, both local disk or SAN or NAS, but you could also utilize cloud storage or having hybrid or combination of both. MySQL is extremely versatile and rich of functionality. Currently, MySQL have active installations of 1.5 million across the globe, start from very tiny database size until multi-petabytes of database size supporting mission critical system. Kubernetes, in the other hand, is an open source container orchestration system whereby it facilitates the cloud native to run containerized service, application, and database. The diagram shows the high-level architecture design for MySQL to run Kubernetes. As you see there, it is really similar as running MySQL on VM. I do agree with you if you think that there are a lot of fundamental technical differences between virtualization and containerizations between VM and Kubernetes. However, this talk is not about Kubernetes. So let's put aside the fundamental differences and look at only on similarities between both to make all of us easy to understand how MySQL runs on Kubernetes, as I believe most people here are already familiar with MySQL on VM. In VM, you have VM host. In Kubernetes, you have Kubernetes worker node, the physical layer of bare metal or bare metal's server of the Kubernetes cluster. In VM, you have VM instance that can run multiple workloads. In Kubernetes, you have pods that can run multiple containers, whereby each container will run single and specific workload. To spin a pod, you need to specify the container and the container image that consists of operating system and fully set up application or database. In VM, if VM instance is crashed, the VM will start on the same VM host or different VM hosts based on our customized configuration. Kubernetes will do exactly the same thing. If a pod is crashed, then Kubernetes will start the pod on the same Kubernetes worker node or different worker node based on the pod definitions. Let's go deeper. This slide talks about MySQL container on Kubernetes. In order to spin new MySQL database on Kubernetes, it requires MySQL Docker image. MySQL has two Docker images, which are Community Edition that you can download from GitHub, and Enterprise Edition Docker image, which are only available on support.oracle.com. To deploy MySQL, you need to have definition, and definition is formatted as YAML file. There are various ways to deploy workload on Kubernetes. We can use stateful set, deployment set, replica set, or daemon set. However, I personally strongly suggest to use stateful set to deploy MySQL database. Stateful set will allow us to scale MySQL database within a single stateful set because stateful set allows storage provisioning to be scalable to make each MySQL container to have its own storage space using auto-scale definition of persistence volume, which is PV, or persistent volume claim, which is PVC. If we use deployment or replica set, then the PV and the PVC cannot be scaled, and therefore all MySQL database instance within a single deployment or replica set will mount the same storage and database files. It is not possible on MySQL because each instance needs to connect to its own database file. In stateful set, each pod will be given dynamic IP address and host name or pod name with format stateful set name dash index as you see on the screen. Let's say you have stateful set name as MySQL with only one replica. Then there will be a pod created with host name or pod name set as MySQL-0, as you see on the screen. If you increase the numbers of replicas into 2, then there will be with host name or pod name with as MySQL1. In order to reach MySQL run on Kubernetes, right? Run on containers on Kubernetes, we cannot connect using dynamic IP address since it will be dynamically changed by Kubernetes each time a pod gets restarted. We need to have service, and we can use service name as our database connection endpoint definition. Then this is the important point. In order to have consistent experience for MySQL when running on VM, bare metal, or even Kubernetes, if we run this on Kubernetes, we should set service name that tied with the pod to be equal to the host name and the pod name, right? Host name and the pod name. By doing so, no matter our database run on Kubernetes or VM or bare metal, we can use host name as our connection endpoint definition to connect to the MySQL database. Since option file inside the MySQL Docker image is using /var/lib/MySQL as data directory, then persistent storage has to be mounted as /var/lib/MySQL through PV and PVC definition as you see on the right diagram. Therefore, database file can be persisted on storage. This slide explains about stateful set definition in the YAML file. You need to specify that this is a stateful set. You need to specify the replicas that represent the numbers of pods or MySQL database that can run on a single stateful set. You also need to specify the image used to spin the container within a pod. And finally, the storage definitions using PVC that mounted as /var/lib/MySQL inside the container, and MySQL will use that to persist each database file on storage disk. All right, before I jump to the backup and recovery, I would like to switch to the demo mode. However, since I I was not able to share the whole entire screen, then pardon me if I stop sharing for a while, just to switch my shared screens to the terminal. Yeah, hope you can see my screen. It is a terminal over here. All right. So first of all, I already installed Minikube in my laptop. And inside Minikube, as you see over there, I have already, two pods, which is backup servers -0 and DB server -0 that I'm going to use it for my demonstration. And I will create the InnoDB cluster later on. I will create a 3 pods, okay, just to show you how to do backup and recovery, just to show you how to provision MySQL instance on the Kubernetes. So first of all, I would like to show you how to see, right, list of the namespace that installs on my Kubernetes. As you see over there, okay, there are a lot of namespace. What is namespace in Kubernetes? In short, namespace is easy. Namespace is just like a compartment that can divide resources in Kubernetes so that it can be manageable. And then, as you know, if we create MySQL, if we deploy MySQL on VM or bare metals, normally we use MySQL D, -- default files, and then we can choose initialize or initialize insecure. If we choose initialize, then database will be created in data directory with the random password. However, in Kubernetes, we don't want to have random password for this. So that's why we need to set the root password, right, to something else. And then actually in Kubernetes, we can store this password as a secret within the Kubernetes cluster. So this is the command basically to see list of secret that available in namespace called MySQL -cluster. So I create namespace called MySQL cluster. I create secret names as MySQL root password, and I'm going to use MySQL root password secret, the content as root password whenever I set up the database in my demo. So as I mentioned, that in order for connect to the database inside the pod, right, inside the container, inside the pod, then we need to have services, and services basically have to be set. The name have to be set as the pod name, as you see over there. That I have namespace called MySQL -cluster, and inside the namespace I have services. And if I run that command, then I will get all the services inside the MySQL clusters namespace. And as you see there, the name of the services are the same as the pod name. If I list pod, this is the name of the pod, and if I list the services, and this is the name of the service name, right? So in order to show database on DB server 1, this is the command basically. So kubectl is the tools for me to connect to DB server 1, and then -- followed by MySQL command line, usual MySQL command line. As you see over there, I already have Vault X being set up, the additional schema. If we deploy MySQL for the first time, empty vanilla MySQL on Kubernetes, then the same thing that we get if we deploy on VM or bare metal, we only get information schema, MySQL, performance schema, and sys. So yeah, DB server 1, DB server 0, I already deployed our Vault X schema. So in order to create 3 node of the Kubernetes nodes, MySQL on Kubernetes, this is the YAML files definition, as you see over there. Oh, sorry. Yep. Namespace is MySQL -clusters. The name is node, and I specify that this YAML file is a stateful set YAML file. And this is the image, and then this replica. So once I run these YAML files, I apply this YAML file, I will get 3 additional pod running in MySQL cluster namespace. And this is the storage definition, PVC, and then I mount this PVC to /var/lib/MySQL. So let's start it. kubectl apply -f and followed by the YAML file. Quickly, once it's done, then we can see the progress, whether the MySQL is already deployed properly. As you see over there, okay, node 0 is still creating. Node 0 is done. Now kubectl is doing for node 1. Node 1 is done, and now doing node 2. So by simple definition and by simple command, actually in almost less than a minute, we can have 3 MySQL database servers running on Kubernetes. So in order for this database service in Kubernetes to be able to connect from outside of the container, then we need to have a service. And so I created 3 services, which is node 0, node 1, and node 2. So the service name there are the same as the pod name, as you see. So if I'm going to list off the service running on my namespace, there are 5 services right now, which is node 0, node 1, and node 2 are the new services that I just created by issuing command kubectl apply -f and then create service.yaml file. If you want to see what is the YAML file definitions for create services, this is the YAML file. All right, so we have already 3 MySQL database servers running in our Kubernetes, our small, simple Kubernetes cluster. I'm going to stop sharing, and I'm going to go. I'm going back to the presentation mode, and explains about backup and recovery. So this is the backup and recovery portion. So as you see over there, hopefully you are with me right now, okay, seeing the PPT about logical backup using new MySQL Shell API. So I would like to share with you that on MySQL 8.0.21, we have enhanced the MySQL DAM. Now MySQL has logical backup similar to MySQL DAM, but a lot better. The logical DAM or logical backup can now be done in completely online, non-locking with parallel threads. By default, numbers of threads is 4, and good compression ratio. It can backup entire database or just selected database and compatible with 5.7 and above. You can do this by using MySQL Shell 8.0.21. As you see on the diagram on the screen, I will need a MySQL container running as a backup server, and this container is special because it mounts the PV and PVC as /backup and not /var/lib/MySQL. This because I need to use /backup to store my dump files. The backup server pod will also run internal MySQL instance, but we don't care about that because we don't need this database. It's just a dummy database that's used to make backup server run on Kubernetes. And the MySQL database instance uses /var/lib/MySQL as data directory that has nothing to do, nothing related to the process on storage. It has default MySQL database that store metadata and make MySQL to run only. No data shall be stored in MySQL that run on this backup server. If you use Docker image of 8.0.21, you will have MySQL Shell with the new DAM API with new logical backup feature. As you see the pod on the left, it is a target database. MySQL over there is running using /var/lib/MySQL to store database file on persistent storage. Before I forget, I would like to share with you that you need to have config map to replace socket file definition in default option file or my.cnf of MySQL. if you want to run on a full-blown Kubernetes cluster, or else MySQL will crash. So here, in backup recovery, the backup server can make connections to the database pod using service as DNS lookup to reach the database and run utility to dump the database file to backup server or restore dump files from backup server to MySQL database target pod. Here is the logical backup, how it can be done on Kubernetes. To backup database, you might need to connect to backup servers using command that I've written on blue colors and run MySQL Shell dump instance inside backup server by connecting to target database written on red color in these examples on your screen. To connect to backup servers, you need to use kubectl and mention the namespace followed by the pod name of the backup server. The command line continue using MySQL Shell, run inside backup server to run dump instance to dump database target to /backup directory that inside the backup server. So the /backup will be on backup server, not on the database target. Using the same model, we can restore database dump from backup server to the target database. You might need to connect to backup servers using command line on the blue color and restorations using command line written on the red color. The command will read /backup on backup server and apply those backup dump to the target database. For your information, the portion of those commands that written on the red color are purely MySQL command line. The same command can be applied for MySQL when it is running on bare metals or VM. So in Kubernetes, there's not so much different in terms of management of database and in terms of command line. It's the same command, but we are working on Kubernetes. We just need to put the command after Kubernetes portion that use kubectl utility. Another technique to do online backup and recovery is utilizing the clone plugin. The clone plugin is available since MySQL version 8.0.17, and since then, it has been fundamental technology that enhance many other features of MySQL, like for example, InnoDB Cluster, kube replication, and InnoDB replica sets. The clone of database can be online, and it will clone the entire database tables that uses InnoDB storage engine. If there's table that uses non-transactional storage engine like MyISAM, the clone will create an empty table with the same structures of the clone on the clone instance, but without migrating the data. The same thing can be done on MySQL container. By using service, both clone source and target can communicate each other as you see on the right diagram. First of all, we need to install clone plugin on the source database one time only. I repeat, one time only, because we don't need to reinstall the clone plugin each time we want to clone. On the target, we need to spin MySQL database and its service on Kubernetes. Install the clone plugin first and run the cloning procedure. Any data that resides on target server will be wiped out and replaced by data from source database. This includes database object, users, and grant table. Here the technique, very simple. You just need to install the clone plugin on source database, create users for target database to connect, and grant backup admin privilege. On the target database, you just need to spin MySQL container, install the and setting variable clone valid donor list to allow cloning from source database. On variable clone valid donor list, you need to specify the source database host name or pod and the pod. Yeah. Once done, you need to execute the clone instance. Just that. All these commands are able to run as a single command within kubectl. As you see on the screen, they are only single command, but inside they have two portions, right? The second portion consists of a couple of MySQL instances that can combine together into a single kubectl. So now I would like to switch to the demo mode. Apologize that I need to stop sharing and go back to my terminal. I would like to share my terminal now. Right, as you see on the screen, hopefully you are with me, okay, seeing the same screens, right? I share the terminals. I would like to conduct a demo on backup and recovery. First of all, I would like to share with you the conditions of the backup server. Inside backup servers, like I already mentioned, I already have the slash backup directory, right? And then this command basically tell me that nothing is inside the backup directory inside the backup server 0. And now I would like to do a backup using MySQL Shell dumb instance. And I will connect to, from backup server 0, I will connect to DB server 0 and start util.dump instance to dump this instance into slash backup that reside on backup server 0. Done, just that. So if I want to show again the same directory on my backup server 0, now my directory already have the backup dump of MySQL, DB server 0, right? So now I would like to show to you, this is the restore, this is the backup part. Now I would like to show to you the restoration part using this, backup dump. First of all, okay, remember that I already have 3 additional ports, which is node 0, node 1, and node 2. Now I would like to restore this backup file into node 0. First of all, I need to set, prerequisite first on, node 0 to be able to restore the dump files into a database that run on node 0. First is to set persist a local infile equal to on. Then I will need to create a user in node 0 database so that my backup servers will be able to connect to node 0 database and restore the backup file. All right. So as you see over here, I would like to show to you also that there is nothing currently inside the node 0. Yep. There are only 4 default schema, which is information schema, MySQL, performance schema, and sys. While in the backup in the DB server 0, I already showed to you that it has workx schema, right? And I already do backup to the backup server 0. So now I would like to restore the backup from the backup server 0 into this node 0. Done. So now I would like to show to you using the same command. Show database on node 0. Now I already have workx. So this is the way how to do backup dump and then restore dump on MySQL Shell 8.0.21 on Kubernetes. And now I would like to show to you how to do. I would like to show to you how to do, backup, clone from, from source to the target. I already do, on node 0. Now I want to switch to node 1. I want to do cloning from DB server 0 straight away directly to node 1. Remember, I'm going to use clone plugin. I don't have to, involve any backup server over here. I already installed clone plugin on DB server 1, so I don't have to install again. I just straight away go to the node 1 database. I'll show you. In node 1 database, I don't have workx. So now I want to show to you, if I'm querying something from workx, then it will give me an error because I'm connecting to node 1. Now I want to do cloning from DB server 0 to node 1. Just simple. Copy and paste this command and run it. This command will install the clone plugin and then set persist clone valid analyst and clone instance from clone DB server 0 3306 identified by clone. So it will create snapshot on the DB server 0, and then send the snapshot over and restore into the node 1. Then if I run the same command, exactly the same command, show database on node 1, node 1 will show that it already has word X. Then if I select city tables inside the word X from node 1, as you see over there, then it already contains the data. So yeah, I'm going to go back to the presentation mode right now. Yes. Now I'm going to explain to deploy InnoDB clusters on Kubernetes. I will talk a little bit about InnoDB cluster since there is no sessions about InnoDB cluster over here. The InnoDB cluster is high availability solution that provide cluster that can auto-manage database replicas. The foundations of InnoDB cluster is group replication and add features like MySQL Shell admin API and MySQL routers that can be fully integrated solution and automated. It can provide write consistency. Whenever there is new transaction, it will replicate over into all InnoDB cluster members with a recovery point objective equal to 0 or no data loss at all. In any time, the write can be done on nodes that run as primary, while query can be either on primary or secondary nodes. Therefore, InnoDB cluster is read scalable. It is virtually synchronous using Paxos, whereby the first transaction to commit will win, and the transaction has to be certified with most of the nodes members agree on the transaction. If the primary node down, then the cluster will be automatically nominating one of the secondary node as a new primary node. If the crash node is restarted, it will auto rejoin to the cluster. The client applications will need to connect to MySQL routers using either read-write port or read-only port. If using read-write port, the router will automatically redirect the application connection to the primary node of the InnoDB cluster. If there's primary node failover, the router will automatically redirect the connection to the new primary. If application is connecting to routers using read-only port, then the connection will be redirected in round-robin fashion to all secondary nodes. This application does not need to know, does not need to be cluster aware because of the routers. It is suggested to run MySQL routers on the same servers as application to streamline the maintenance, cut network hop from applications to database, and we don't need to install routers in high availability fashion. On Kubernetes, we can run router, containers, and application container into a single pod. This is how it looks like in Kubernetes. We have stateful set name as MySQL with 3 replicas. Then we will have 3 pods named as MySQL-0, MySQL-1, and MySQL-2, as you see on the screen. Each pod has its own storage space, PV, PVC, dynamic IP address, host name, and services, whereby service name has to be the same as pod name or host name for each. This is very, very important, that service names must be the same as the pod name, because group replication framework stores host name on the DB in a InnoDB cluster metadata for connections between cluster, and it can be used for many, many more functionalities within the cluster. To set up InnoDB cluster on Kubernetes is surprisingly straightforward. The steps and the commands are the same as if we run InnoDB cluster or bare metal on bare metal or VM. First, we need to do configure instance on each MySQL database. The configure instance will set up the system variables of database to be able to run group replication and join InnoDB cluster. The configure instance will set up cluster admin with cluster admin password for administering the InnoDB cluster. If the variable change require restart, then the command that I presented on the screen will auto restart the database within the pod. Please use these commands against Docker image 8.0.21 only. I repeat, use these commands using Docker image 8.0.21 only. The previous MySQL Docker image release it will fail the restart, and you need to delete the pod manually to restart the pod and the container. However, we fix this issue on latest release of 8.0.21, which is the latest release of MySQL that just came up about maybe 2 to 3 weeks ago. With setting interactive equal to false in the command line, as you see on the screen, we grant permissions to the configure instance to proceed changing the variables without asking for our confirmation. Once configure instance done, then we can create cluster on node 1, then follow by adding node 1, we can create cluster on node 0, yeah, which is the node 1, but I name it as node 0. So sorry for confusion. Then follow by adding node 1 and node 2 into cluster from node 0. Then we have 3 nodes InnoDB cluster already run on Kubernetes with only 6 command line. Can you imagine? Only 6 command line. And because we are using PV and PVC, the configurations of InnoDB cluster will be persisted on this. Then we don't need to have like, operators as mandatory requirement in this case. Whenever the pod getting restarted, the database is getting restarted within the pod, and it will load the persistence variables as well as the InnoDB cluster metadata inside the database. And the database that run on the pod that just restarted, it will do auto rejoin back to the cluster. Imagine 6 command lines to deploy InnoDB clusters on Kubernetes. 3 command lines on the previous slide for running configure instance, and another 3 command lines in this slide for configuring the cluster. So this slide basically talks about MySQL router configurations on Kubernetes. As you see, you will need to have YAML file definitions on MySQL for MySQL routers as stateful set. In order to bootstrap routers on Kubernetes, the YAML file will need to mention MySQL password as cluster admin password, MySQL users as cluster admin user, host as primary node at that point, at a time and port. After bootstrap, routers will create a database on InnoDB cluster for routers to connect. Therefore, I suggest for routers to be deployed as stateful set. I understand the concern here that people like to deploy MySQL application on Kubernetes. Application, yes, on Kubernetes as a replica set or deployment. But if we are going to deploy routers as stateful set, then I suggest to decouple application and router into separate pod. I will change to demo mode, and I will go back to presentation mode to go to the summary. I will stop sharing for a while, and then I will go to the my demo. All right, hopefully you are with me now. See the red terminal over there.
No problem.
Oh, yep, node 0. We need to configure instance on node 0. Then we can just change. We can just run something like this. And immediately node 0 become ready for InnoDB cluster. It will set, it will restart, and no problem. We don't care. We just proceed with node 1. And now we are proceed with node 3, or the third node of the InnoDB cluster. Once done, then what we can do, we can create cluster. Connect to node 0, run MySQL admin, MySQL Shell, and then a DBA create cluster, and name our cluster as my cluster. Done. We already have MySQL InnoDB cluster, but only one node. Only one node. And the node are node 1, node 0, sorry, and it is run as a primary. So we can add instance with a simple command. We can add instance node 1 into the cluster. Connect to node 0, and then use a cluster add instance, and then recovery method equal to clone. Therefore, the clone plugin will kick in. Clone plugin will start to clone over from node 0 to node 1. All the database on node 1 will be wiped out with the content from node 0. And once done, the node 1 will be, starting up, restarted, and it will auto rejoin to the cluster as, secondary node. So we are waiting for the server restart. It's a bit taking time. After this, we can do, joining the node to the cluster. Usually, the first one is taking a little bit time. The second one, it may be getting fast. Yep. So I will prepare the command for, joining the node 2 and node 1 to the InnoDB cluster. Yep. This is the joining the node 2 to the InnoDB cluster. I connect to node 0, and I run MySQL Shell, and then cluster add instance and recovery method equal to clone. Same process as node 1. Then the node 2 database content can get wiped out, okay, by clone plugin from node 1. To be honest, like you see on the screen, it is taking from the node 1. So the clone plugins create the snapshot on node 1 and send the snapshot over to node 2 to wipe out everything on node 2. And then once node 2 getting, the clone is completed node 2, then node 2 will be auto restarted. And then once it is auto restarted, it will auto rejoin to the cluster. So I will show to you, right, the cluster status after node 2 back online, alive. So yeah, we need to wait for a while. Yep. So now we already have 3 node InnoDB cluster with primary node set as node 0. Node 1 and node 2 become secondary node. So apologize that I'm not going to, taking times for, failover process and so on, because time is limited. I will go back to the presentation slide and, do the summary. Oh, sorry, not this. Yep. So MySQL and Kubernetes, what works? As you see, we can deploy MySQL nodes on Kubernetes. We can mount the storage volumes. We can deploy the binaries easily. We can restart instance if this fail. We can upgrade MySQL. Of course, we cannot go through with this, but we can download the new MySQL binary and just replace the YAML file definitions to use the new template, the new image. Then suddenly MySQL can get upgraded. I already show you how to do backup and restore using clone plugin and MySQL Shell, MySQL download instance. If time permit, and next time probably I can show to you how to do it using MySQL Enterprise Backup. And we can do monitoring using MySQL Enterprise Monitor and other tool as well. So why MySQL in microservices? To summary, MySQL is widely adopted. MySQL is for DBAs and developers. MySQL is available in application layer as well, available in Docker image. MySQL is multi-model approach. It's lightweight, executables, and it can be, hybrid database, SQL and NoSQL. MySQL community is 100% compatible with MySQL Enterprise Edition. However, if you have stringent requirements on security, you have stringent requirements on the high availability and so on, especially having the support from principal like Oracle, then MySQL Enterprise Edition is the right choice to go, because you cannot get those features available in MySQL Community Edition. So okay, I thanks for the time. If you have time, probably you can visit my blog, mysqlsg.blogspot.com. And inside my blog, I already explained on how to install Kubernetes. How to install and deploy MySQL InnoDB cluster on Kubernetes, routers on Kubernetes, and so on. You can see there about my works on MySQL on Kubernetes. thank you so much. I stop sharing and thank you so much.
Okay, thank you for sharing from Hananto.
Thank you so much.
Okay, thank you.
Thank you.
像我们这个，像他做的，他如果说这个 demo 做的完整，可以做得非常漂亮。他这还写了一个小小的客户端，从前端去 access router， 然后从 router 打到你的 primary， 你可以看它那个图呢出来的时候是展现出来 router 那个丢到正确的 primary 上面去，然后你 primary 关掉的时候，它把你 failover 过去，而且自动 failover。然后 fail 完了以后呢，你那个当初被关掉 primary 再把它带起来的时候，它又重新加回来，所以可以看得到，它这个加回是自动加的，也不是我们用手动加的，就是只要你的那个节点，就是那个 Kubernetes 节点带起来的时候，它就会自动加回来，所以可以做到非常好的 resilience， 就是那个强固性可以做到非常好，所以可以看到非常明确的一个从 Kubernetes 跟MySQL中间的一个结合的过程。